Alright, so let's take a look at inverse Laplace transforms. So here we have the inverse Laplace transform of 1 over x squared and 1 over s squared minus 1 over s plus 1 over s minus 2. Alright, so when we're doing the Laplace transforms, we have a table that we can look at. So here we have this table, and the first one that we're looking at, you can see, is 1 over s squared. So let's see what matches that. Alright, so here we don't have a 1 over s squared that we can see, but if we look at this one, this number 3, we have s squared in the denominator. So we can rewrite that as s to the 1 plus 1, and you can see n would be 1, so that would be 1 factorial up here, which would just be 1. Okay, so let's rewrite that. That's going to be the inverse Laplace transform of s to the 1 s to the 1 plus 1 Alright, now in this problem n is 1, so that would be 1 factorial up here, and we do have 1 factorial, which is 1. So we'll rewrite that as 1 over s to the 1 plus 1. Okay, minus 1 over s. Well, let's look at this. You see the 1 over s? Well, that's just equal to 1. So we'll leave that as 1 over s. So that's 1 over s plus, now we have 1 over s minus 2. So let's see if we have something that looks like 1 over s minus 2. Well, if you look here, we have 1 over s minus a. And in this case, a would be 2. And you can see the inverse Laplace transform of that is e to the at. Alright. So we'll leave it as 1 over s minus 2. Alright, so here, if we take the inverse Laplace transform, remember the inverse Laplace transform of this, now that we have it in that form, in this form here, that's t raised to the n. And what's n? Well, n is 1, so that would just be t. So this is t minus, and then remember 1 over s is 1, and then 1 over s minus 2 is this one. A is 2, so that would be e to the 2t. So that would be plus e to the 2t. And this would be your answer. Alright, let's take a look at another one. Alright, here we have inverse Laplace transform of 4 over s plus 6 over s to the 5th minus 1 over x plus 8. Alright, so let's take a look at our table. Let's look at this 4 over s. So you can see we have 1 over s. So what we want to do is, let's split this up. This is going to be the inverse Laplace transform of 4 over s. But remember, in the formula, there was a 1 up here. So I need the 1, so I'm going to take this 4 and bring it outside. Okay, plus, now I have 6 over s to the 5th. So let's take a look at this one. Well, once again, I'm going to use this number 3. I have s to the 5th, so I can write that as 4 plus 1 as my exponent. So that means that in the numerator, since n is 4, I need a 4 factorial. Okay, well, Notice I have a 6, but I need 4 factorial. So what I'm going to do is I'm going to bring the 6 out in the inverse Laplace transform. Let me erase this. I'm going to need a little more room there. This is going to be the inverse Laplace transform. And I'm going to rewrite s to the 5th as s to the 4 plus 1. Now, I need a 4 factorial because n is 4. So I'm going to multiply here by 4 factorial. And when I do that, I have to come out here and divide by 4 factorial. Okay, so that's the same thing as multiplying by 1. And then minus the inverse Laplace transform, I have 1 over x plus 8. So let's see what we have here. Well, we don't see an s plus 8 anywhere, but we do see an s minus a. So I'm going to rewrite s plus a as s minus negative a. And I wrote the problem wrong here. That should be an s. Alright, so now I have this in the form s minus a. Okay, so for our table, I have 1 over s is 1. Okay, so this would be 1. So 1 times 4 is 4. Plus, and then look at this one, 4 factorial over s to the 4 plus 1. Well, n is 4, so that would just be t to the 4th. Okay, so let's see, 4 factorial is 24, so that would be 1/4, and then that would be t to the n, and in this case n is 4. And remember, 4 factorial, if you remember that, 4 factorial is 4 times 3 times 2 times 1, which is 24, so 6 over 24 is 1/4. Alright, so now this last one here, that's in this form, so that's e to the at, and in our problem, a is negative 8, so that's minus e to the negative 8t, and this would be our answer. Alright, so I hope this video's helped. I'm going to do some more videos of inverse Laplace transforms. I'm going to do them in separate videos. So if you need some more help, check those out, and they'll get a little more complicated as we go. Alright, thanks.